This video is going to be really introductory to patterns, and algebra is basically based on patterns. We can study all sorts of patterns in many different varieties and through many different strategies. So one of the things that our textbook does is they like to be real visual with the patterns. And so I'm going to show you kind of what the book does a lot. So when you're working on the homework at home, you kind of have something to kind of help you out with. So, or in class, we're working on assignments and things like that. Here's an example of what I'm talking about. Here's a pattern. It's a picture, and all it is these little boxes that are put together. We call this a tile pattern. So it's a picture of a square with 1, 2, 3, 4 boxes in it, and then these rectangles that are getting bigger and bigger. And we can name these, like we could say this first picture here, we'll call it figure number 1. This is the first picture. And this could be figure number 2, and this could be figure number 3. And figure is just another name for like shape. I could say shape 1, shape 2, shape 3. Figure 1, figure 2, figure 3. And basically what you should be able to do is you should be able to look at this pattern and extend it. And extend it means if I asked you to draw figure number 4, it should be no problem. And figure number 5 and figure number 6, and if I told you to keep going, you should be able to continue to go. What you have to figure out is, what is this pattern doing? Is it growing or shrinking, getting smaller or bigger, and by how much? This pattern's obviously getting bigger. The rectangles are getting taller. If I asked you by how much, you would be able to easily tell, like, okay, here's 4 squares. Here's 4 squares. It looks like they added, like, I'll shade them. Looks like they added 2 tiles to the top of the last figure. And then if you look, there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like they added 2 to the top. So if I told you to draw figure 4, you probably wouldn't take too long to figure out that it's just like figure 3, same size, but all I have to do is add 2 more tiles to the top, and that would be figure 4. And if I want, I could shade them too, make them look like this. So something we're going to be doing with these tile patterns is every time we see one, we're going to kind of convert it into a table, another way to organize the information. And so we have 2 things going on here. We have figures, and we have tiles that we could count, little squares that we could count up. So I'm going to write figure number, and I'm going to write number of tiles. And I'm going to build a table out of this. I'm going to build the table going this direction. Not that it matters, but I'm just kind of picking away. And if you look, we had 1, 2, 3, 4 figures that we looked at. So I could fill in this table, and that's what I'm going to do. I'm going to write figure 1, figure 2, figure 3, figure 4. The tiles are going to be counting them up. So like figure 1, if you count them up, had 1, 2, 3, 4, so 4 tiles. Figure 2 had 1, 2, 3, 4, 5, 6 tiles. Figure 3 had 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's a pattern here. 4, 6, 8. You can guess what the next one's going to be. 10. And once you kind of build this table, it's not hard for me to say, hey, can you tell me figure 5 and figure 6 and figure 7? You just kind of follow the pattern. You keep adding 2. So what's the next one going to be? 12. And so on and so on. So some of the things we do is we can show the growth of this pattern by showing at the bottom here that we know it's adding 2, adding 2, adding 2. And that's going to be helpful for us to make predictions down the road. It's still going to be pretty challenging if I all of a sudden said, like, go ahead and draw me figure number 100. How many tiles are in that thing? I could figure it out, and it wouldn't take me forever, but you'd have to add 2, add 2, add 2, add 2, add 2, add 2 until you got all the way out to 100. So it's kind of a pain. So we try and come up with another way to figure these ones out with the really big numbers. We try and come up with a rule. And a rule really makes solving these things a whole lot easier. So I'm going to write down here, we want a rule. And the rule's another shortcut, basically. And here's the way it works. We have 2 things we're studying. figure number and number of tiles. And so what we do is we take these two things, they're changing, like all the numbers continue to change, so we give them a variable. We say figure number is the x variable and number of tiles is the y variable. We have x and y. So the top is our x's and the bottom is our y. And what we try and do is we want a rule so that we can figure out this blank spot right here, the number of tiles. Well, is that an x or a y? That is a y. So we want a rule that figures out what does the y equal. And so figuring out what that rule is pretty challenging. A y equals rule is what we call it. And basically what you have to do is kind of crack the pattern a little bit. And there's a lot of ways to think about this. You're kind of comparing the numbers instead of going this direction. You're comparing the numbers vertically here. So like how do you turn a 2 into a 6? You either add 4 onto it. You could times 2. 2 times 3 is 6. You can times it by 3. You can see if that works on another thing. Let's try 5. If you do 5 times 3, do you get 12? Doesn't work. 4 times 3, you don't get 10. Okay, so timesing it by 3 is not going to work. What if you times these numbers by 2? Like 2 times 4. What's 2 times 4? 2 times 4 is 8. How are you going to make that a 10? You're going to add 2 onto it. 8 plus 2 is 10. Let's try it on another one. What's 2 times 5? 2 times 5 is 10. Plus 2 is 12. If I do 2 times 3, 2 times 3 is 6. Plus 2 is 8. That's my rule. If I times these numbers by 2 and then add 2, I get my answer. So if I take the x numbers and do 2 times x plus 2, I get my answer. And this will work for anything. It'll work for 100. 2 times 100, so I'll do it over here. 2 times 100 plus 2. Well, 2 times 100 is 200. And if I add 2 to that, that will be 202. So figure 100 has 202 tiles. And I didn't have to draw that giant 202 tile picture because I used my rule to figure it out. Now, in algebra, we usually use the dot for multiplying. This little dot here, it means 2 times x. But with a variable, you don't even really have to put the dot there. I could have wrote the rule as y equals 2x plus 2. And I think that's a little simpler. I'm going to circle that thing. That's my rule. And it's going to work all the time. Multiply by 2, add 2. So try it on the 1. What's 2 times 1? 2. Plus 2, 4. So it totally works. It should work on everything. So one big thing out of this chapter is we kind of try and convert. We try and draw the pattern, make the table, and write the rule. This is the hard part, is writing the rule. This is the part people get stuck on. So let me show you another pattern, a different problem. And pause the video and copy it down if you need to. Here's our pattern. It's got 3 figures. They're not labeled, so I'm going to go in here and label them. We can call it figure 1, figure 2, figure 3. Or let's be different this time. Let's say somebody shows up and calls this figure 0. Okay, there's the 0 figure. And then they said this is figure 1. And this last one would have to be figure 2. You should be able to take this pattern and extend it. If I asked you to draw figure 3, hopefully it's not too big of a problem. You should pause the video and try it. Draw figure 3 and then check your answer. Okay, so here's what's going on if you pause the video and tried it. Figure 0 has 3 tiles. Figure 1 has 3 tiles, but it has an extra one added to the top here. Figure 2 has 1, 2, 3, 4, 5. It has like this extra tile added to the top. So it looks like the pattern's growing by 1, adding 1, adding 1. So figure number 3 is just going to get a little bit taller. It's going to have an extra 1 on top. I think it's going to look like this. It's going to have 1, 2, 3, 4, 5, 6 tiles, and I can shade the top one to kind of show that that's what I added on. It's going to be pretty easy to take all this information and convert it into a table. We're going to have 2 things. We're going to have figure number, and we're going to have number of tiles. And remember what we did on the last example, how I labeled it X and Y? I'm going to do the same thing here. Figure number is the X, number of tiles is the Y. And I'll build a table. This time we got some different values. We started with figure 0, so that's a little bit different. Means in my figure numbers here, I'm going to start with 0, 1, 2, 3. 3 is the last one that we did. And for number of tiles, I'm just going to count them up. So figure 0 has 1, 2, 3. Figure 1 has 1, 2, 3, 4. Figure 2 has 1, 2, 3, 4, 5. Figure 3 has 1, 2, 3, 4, 5, 6. Pretty simple pattern. I can tell what it's doing. It's going up by 1. So each time I go up by 1. So if I asked you to find figure number 4, it's super easy. You just say 6 plus 1 is 7. Got it. Figure 5, figure 6, you can keep going, make this table really big. Might get not super hard, but a little harder if I get into real big numbers. Like if I said, you know, what's for figure number 180? Something big. Can you tell me what it is? So you just have to add 1, add 1, add 1, add 1, and you'd figure it out eventually. A rule would make this easier. So if I can come up with a y equals rule, because I want to figure out a y value, that's my blank here. I want a y number. If I can come up with a rule, it's going to make things so much simpler. So remember how to do the rule. You look at the numbers going up and down here. You ask yourself, how are you going to turn a 2 into a 5? How are you going to turn a 3 into a 6? And a 4 into a 7? And so on. So like, pick any number you feel like. I'm going to use the 3. How can you turn a 3 into a 6? Well, you could times it by 2. So 2 times 3 is 6. That works. Try it on something else. Is 2 times 4 going to give me a 7? 2 times 4 is 8, not 7. Try it on 0. 2 times 0 is 0. So that's not 3. So that's not going to work. So try something else. What about, how else can you turn a 3 into a 6? How about add 3 onto it? 3 plus 3 is 6. So try that on another one. What's 4 plus 3? 4 plus 3 is 7. Sweet. Okay, what's 1 plus 3? 1 plus 3 is 4. What's 0 plus 3? 3. Okay, so adding 3 gives me my answer. So my rule is I take the x number and I add 3. X plus 3. So 180 plus 3 is going to be 183. Use my rule. Now it's going to be easy. I could ask you, how many tiles does figure number 1075 have? And you would add 3 and say 1078. It'd be that simple. So we got 3 major things here. We've got our pattern. I'm going to label these. We've got our pattern, we've got our table, and we've got our rule. And notice how they're all connected. All 3 things are representing the same thing. It's a pattern growing by 1, getting 1 bigger each time. It's got a rule where if you take the figure number and you add 3 to it, you figure out how many tiles are in it. And you can see the growth in the picture, so it's all right in front of you. And that's what Chapter 3, Chapter 4 in our textbook are all about, being able to do these things. The next step is we're going to learn how to graph it.